Once upon a time, about 3 years ago, a student told me a story of how she and her mom were working with some pool chemicals, and some of that pool chemical got in her mom's eye on accident. She, having just learned about the NFPA labels in my class, checked the back of the chemical that her mom had gotten in her eyes, saw the label, and immediately rushed her mom inside and started flushing her mom's eyeballs under the sink water. This is the story that I was told during a parent-teacher conference. And what a wonderful story to have been told that my lesson was applied in real life to save her mom's eyeballs. So there is a genuine reason to understand what OSHA and NFPA labels mean and what you can look for to determine how safe a chemical is and what you should do in the event said chemical ends up getting on you or, unfortunately, in your eyes. By the end of this lesson, you should be able to recognize OSHA and NFPA labels on chemicals or out and about. You'd be surprised how many you'll find when you're looking for them, and know what those all mean. So first we're going to be talking about what OSHA labels are and what they each mean. Then we're going to move on to NFPA labels, which is the thing above my head, and what each of those quadrants means and how do we read them. Then we're going to go on a little field trip and we're going to identify NFPA and or OSHA labels in the real world on real items. These are some really common OSHA chemical symbols that you may or may not have seen at some point in your life. I want you to kind of look at these pictures and think, what could each of those pictures represent? What could they mean? And then we're going to kind of go through them together. So that first picture, all the way over there, is showing something pouring out of a test tube and onto a human hand and onto this black rectangular thing. And it looks like it's melting it. When you see that picture, hopefully you assume that whatever that chemical is or whatever those drops coming out of the test tube is something that would literally melt a human hand or melt whatever that rectangular black box is. We would call that corrosive. Corrosive is something that will literally just deteriorate something it touches, melt it, if you will. So if you see that OSHA label on a chemical, probably best not to get it on your skin, and probably best not to get it on, I don't know, a piece of jewelry you might value. Next, we've got a little dead fish next to a tree. So pretty gruesome. Fish is belly up. He's gone belly up. And that OSHA label implies that there is an environmental hazard, specifically to do with aquatic environments. If this label happens to be on a chemical, you may not want to get that chemical into, let's say, I don't know, a river or a stream, and you may not want to dump it down the toilet or the sink or something so that it would pollute the waterway. Don't want to do that. For our next Occupational Safety and Health Administration, i.e. OSHA, label, we have a black tube of some kind, and that is showing basically compressed gas. So you have gas under pressure, i.e. don't like shoot it with a gun, don't like puncture it, don't drop it, it could go bang. The next OSHA symbol is a skull and crossbones. So obviously that's implying that the chemical therein will turn you into a pirate. So drink it immediately. No, please, no, honestly, don't drink it. That means it's poisonous. Toxic or extremely toxic, i.e. you die, you turn into skull and crossbones if you ingest it. So don't drink it, you won't turn into a pirate, I promise. Don't. Next OSHA chemical symbol is an O on fire, and that is symbolizing an oxidizer. O stands for oxidizer, meaning that it may cause or intensify a fire. So it's something like oxygen, hence oxidizer, and fire needs oxygen to burn. So it's something that will basically make a fire worse. The next symbol shows a human silhouette, and it shows that there's this star kind of like exploding in their chest. That's not a good thing if you have like something exploding in your chest. Kind of a bad thing. So that is symbolizing a health hazard or harmful to health in general, to human health. And that could be anything from cancer causing to mutagenic, so it could cause birth defects, could make you really sick, anything like that. So harmful to your health. The next one is a fire king, ooh ha ha. And whenever you see a fire symbol for OSHA, that means it's highly flammable. So whatever that chemical is, it can go, up in smoke, so to speak. Now, the one above my head here is an exclamation point. It doesn't necessarily mean like, woohoo, it's a chemical. It means that there's actually a health hazard. And that's also a different health hazard than the harmful to health previously. So you could have both of those labels on the same thing, but we'll go into more depth about the differences between the two here in a second. Next and finally is this like CD looking thing, or like a circle that's going kaboom. Hopefully you get the point there, and that is supposed to be potentially explosive. That OSHA label means it was supposed to make an earth-shattering kaboom. Okay, so you might be thinking, that's great and all, Duckonta, but what do all those words even mean? Like, most of us have heard of flammable, but like oxidizer, low-level hazard, corrosive, like all those things are kind of foreign terms. So let's go through some of these together. Flammable is obviously something that will go whoosh, it goes fire, right? Those are your self-heating chemicals. Those are the ones that can emit flammable gas or give off gas that's flammable. They can also be self-reactive, so things that react essentially with themselves, internal turmoil there much, and organic peroxides. When we talk about things that are explosive, those are things that go kaboom, and they kind of have a similar definition to the flammable items. They're also self-reactive chemicals. Again, they can react with themselves, so they've got that internal strife thing going on, and they can also be organic peroxides. Corrosive is a term that means it's basically like melting away your skin, like we talked about before, but in better terms, it's basically burning your skin, or it's causing severe eye damage if it were to get in your eyeballs. So kind of a reason to wear glasses or goggles when you're working with any kind of chemicals or in a lab. And the fact that it's also corrosive to metals means that it can literally just melt that metal, or like pull apart those metal atoms off of the metal itself into solution. The poison symbol, the pirate symbol, is meant to show you that this chemical is fatal. It's toxic, so don't eat it. Don't do that. The term oxidizer literally means that it's a chemical that can steal another chemical's electrons. Now, the only reason a chemical would want to do this is because they themselves are unstable and they're trying to become stable. So by stealing electrons from somebody else that has more electrons, they essentially make themselves more stable in the chemical world here. Oxidizers can also be known as oxidizing agents or an oxidant because they want to remove electrons or steal electrons from another chemical. That makes them really unstable by themselves. In other words, these chemicals are not happy with just being themselves. They feel like they need to steal from whatever chemical happens to bump into them in order for them to be happy. And because of that, that makes them highly unstable and thus reactive. These are the types of chemicals that cause other chemicals to burn or ignite, causing a fire. Hence the reason why the O is on fire. So then what's the difference between the exclamation point and the silhouette of the person with the exploding chest? The low-level hazard could mean a number of things. It could be a skin irritant or an eye irritant. It could, make you rub your eyes, make your eyes water. It might not make you go blind or something, but it would definitely be painful. It could be a skin sensitizer, and it could also give acute toxicity. It could give you narcotic effects, and it could also irritate your respiratory tract. And last but not least, a low-level hazard may or may not be hazardous to the ozone layer. What about the silhouette with the exploding chest? That's your severe chronic hazard. And that basically means it's a carcinogen, it's cancer-causing, mutagenicity, so it can cause mutations, reproductive toxicity, can affect your reproductive system and your ability to reproduce and create progeny. Respiratory sensitized, make it, again, difficult to breathe. Target organ toxicity, so it could specifically target, like, say, your kidneys and make them fail. Problem. And there's also the aspiration toxicity, so and finally, we mentioned the environmental hazard. That's our dead little fish guy right there. He's so sad. Look at him. Oh, poor fishy. Belly up. Again, don't get the chemicals in the water. Don't kill the fishies. So let's try this. If we were to look at the bottle of methanol behind me, methanol, by the way, since it ends in OL, is an alcohol, and it's an organic chemical because it has carbon in it. That CH3OH stands for methanol in the organic chemistry world. Now, if we're looking at this bottle, it's got a few labels on it. The only ones we've talked about so far are the OSHA labels. Those are the ones right here on the bottom of the bottle, outlined in red. So according to those OSHA labels, what does that tell us about methanol? Is it flammable? Well, that first one is a fire. So yes, it is a flammable chemical. Is it an oxidizer? If it were an oxidizer, it should have an O with the fire on top. We don't see that, so it's not an oxidizer. Is it a health hazard? Low level or chronic? Low level would be the exclamation point. Chronic is the silhouette with the exploding chest. And that's directly above my head. So yes, it is a chronic health hazard. Is it poisonous? Well, right in the middle, there's a skull and crossbones. And that is what we learned is fatal. Not pirate. Not pirate. It's poisonous. Is it explosive or corrosive? Well, we don't see an exploding bomb. And we don't see the contents under pressure little bottle thing. And we don't see that the hand or the rectangle is melting from the test tubes pouring on it. So it's not explosive or corrosive. And is it an environmental hazard? We don't see any dead fishies, so we're good in that sense. So now that we've talked a bit about OSHA labels, let's move on to the National Fire Protection Association, or NFPA, chemical classifications. It's used for immediate emergency identification. So think about all the firefighters out there that are having to go in and save somebody in a lab or in a house or in a warehouse or anything like that. They don't want to be rushing in to a fire that also has a chemical room in it with like severely hazardous and flammable chemicals in it, right? They would want to know what's in there before they enter it so they know how to prepare themselves and go home to see their family that night as well. So these NFPA chemical classifications are super important. And these are the ones that are the diamond shaped, like behind my head. Each category tells you a little bit about that chemical. Tells you how dangerous is it in terms of a health hazard, how dangerous is it in terms of a fire hazard, and how reactive is it on a scale from 0 to 4 for all of these quadrants. It also has a spot, the little white diamond spot, that has specific hazards for that chemical. So maybe this chemical is like super extra and it has an even bigger problem other than being super flammable, super health hazardous, or super reactive. So let's go through each quadrant here and talk about what each one means and how the 0 to 4 numbers are ranked. We can have anywhere between 0 and 4. 0, typically for all of them, is no unusual hazard, nothing to really worry about. And if you get all the way to 4, that's like the max. This is the worst. This is danger, red flags. So anytime you see a 4 in any of these quadrants, that means bad for that category, like really dangerous for that category. If you see a 0, it means you're pretty good, like that category's fine. And if we're starting in blue, which is our health hazard, if there was a 4 in the blue region, that would mean danger, or it could be fatal, even on short exposure. You're going to need special protective equipment. So let's say the firefighters are rushing in to save someone in a building that has one of these NFPA labels on the door with a 4 in the blue region. They need to make sure they are wearing special equipment so that they can go home and see their families that night. If you see a 3 or a 2 in the blue, that is a warning. So, this is harmful. It could be corrosive. It could be toxic. So again, take special care. 1 is just like, hey, caution, this might irritate you. So remember that was like irritating to your skin, irritating to your eyes, acute toxicity, could hurt your respiratory tract. Any of those things are kind of in that health hazard category. If we move on to red quadrant, or the flammability quadrant, that's the top diamond. That is one that obviously firefighters would care a lot about, hence they fight the fires, right? So how flammable is whatever the chemical is in this room or in this bottle or in this area. And 4 is our big danger. So super flammable gas or super flammable liquid in general. That basically means that if it's above 73 degrees, essentially, it's going to go up in flame. So you have to keep this in a refrigerator kind of thing. So if building's already on fire and the fridge is going to go up in smoke as well, this is going to make the fire a billion times worse if there's a 4 in the red quadrant. If you see a 3 in the red quadrant, that's like, hey, warning, this is a combustible liquid, meaning it will catch on fire. With a flash point, again, that's where it kind of will ignite or become flammable. Below 100 degrees Fahrenheit. So somewhere around there, 100 degrees Fahrenheit, could be below that. Given the circumstances, it could ignite and be flammable at that point. If you see a 2 in the red quadrant, that means caution, hey, better watch out. This is a combustible, flammable liquid with a flash point of between 100 and 200 degrees Fahrenheit. So if you get that chemical between 100 and 200, that's when it can spontaneously ignite and become flammable. The 1 is combustible if you heat it. So, hey, just don't put it on a hot plate or don't stick it in the middle of a fire and you're fine. And the 0 is, again, hey, this isn't flammable at all, like you're good. It's not going to go up in smoke. Now, in the yellow quadrant, the one to the far right in the NFPA label, the yellow is showing reactivity. How reactive is this chemical? 4 is, again, danger, worst case scenario. It's explosive material at room temperature. So kablam at room temperature. Super, super reactive. 3, danger. It might be explosive if you were to shock it with like an electrical shock, could be like static electricity, or if you heated it in confinement, or maybe if you mixed it with water. So something is going to trip this chemical up. It's not very stable. So this is basically like you after having a really, really bad day and that one person says something sideways to you and you just lose your crap. That's like 3 reactivity. You're super unstable at that point and one little thing goes wrong and you're going, ah! A 2 in the yellow section for reactivity just means warning. That means it's unstable. It may react violently if you were to mix it with water, for example. So just kind of like one step down from number 3. 3 could be like, oh, yeah, under confinement or shocked or heated or in water. 2 is like, it might react if you mix it with water. 1, caution, hey, beware. It may react if you heat it up a little bit or if you mix with water, but not violently. So it's not going to like cause any undue harm, but it might make you jump. Which reminds me of this one time where I took a chunk of sodium metal, which is a very soft metal. It's kind of like butter and you slice it off. And I did that in my classroom with my students once in the fume hood. And a funny story, I put it in the water. I wanted to visualize reactivity for them with a chemical mixed in water. And the sodium metal, you know, of course, lights on fire and it does this little dance along the top of the water and it's on fire. And I luckily had the fume hood closed because all of my students were standing around. And I turned my back for like 2 seconds just to tell them what's going on chemically. And kaboom! The whole thing just like explodes in the fume hood. Up goes the water, up goes the sodium, up goes the fire. And, you know, I'm pretty sure I came out of my skin and jumped about 5 feet in the air. And my students were cracking up. So yeah. Funny story about reactivity there. A 0 in the yellow quadrant means that it's not reactive. When you mix it with water, it could be reactive in other ways if you really poked and prodded it, but overall, it's a pretty stable chemical. Finally, we have our bottom quadrant of the diamond, the white quadrant, and that has, again, those special precautions. So is this chemical like super extra and you have to be extra careful with it? So a W with a line through it means water reactive, so don't mix it with water. The OX stands for oxidizing agent, and going back to that whole oxidizing thing we talked about in the OSHA labels, that means that it wants to steal another chemical's electrons, making it unstable, making it really reactive. So in the yellow section, there would probably be a higher number, like a 2, 3, or 4, along with a white area of OX at the bottom. Those two would kind of go hand in hand. So after learning about what each quadrant means, let's look at these 3 NFPA labels behind me, and let's think about which one would be most dangerous to your health specifically. So which one would cause the most damage to your health and why? Hopefully you're looking at the blue region. The blue region is the one that is health hazard. Remember, the red is flammability, the yellow is reactivity, and then the white is any kind of special other news announcements that you need to know about this chemical. Are there any other special dangers? If we're thinking about our health, we need to zone in on that blue quadrant. And we need to look for anything that's bigger than 0, essentially, because 0 would mean that it's not hazardous to your health in any particular way. But 4 would mean it's pretty freaking dangerous to your health. So we're trying to look for the biggest number in the blue, and that would be the first one, 3. That 3 in the blue region is definitely suggesting that that chemical will hurt you. That first one, by the way, also has a 2 in the reactivity region, the yellow region, meaning that it's not very stable and it could react if you mix it with water. Now, if we were going to look at flammability, however, the one behind me would be the most dangerous because it has a 3 in the red area. If you're curious what each of these are, that first one is sulfuric acid. Sulfuric acid is, yes, in fact, very dangerous to your health. I wouldn't suggest getting it on your skin. It is corrosive. And notice that the white area says acid in it. Kind of a dead giveaway that it's an acid. It's not flammable, but it is reactive. If you mix sulfuric acid with water, it does heat up. It's an exothermic reaction. It releases quite a bit of heat. So it does have a reaction with water. It's not very stable. By the way, if you mix sulfuric acid with sugar, you create this gnarly looking black monster that smokes out of the abyss. I used to love to do that lab experiment with my students, and we'd call the fume hood monster from the depths of the fume hood chemical hell. And it would come forth out of the blacktop and smoking and flaming curl over. The middle NFPA label is representing water. Notice there is 0, 0, 0. Water isn't flammable. Water isn't a health hazard. In fact, you need to go drink water. If you're not drinking enough water, go do it. Drink water. And reactivity is 0. Water isn't really that reactive either. What's the NFPA label behind my head? That is the NFPA label for isopropyl alcohol. So that stuff you put on your boo-boos, your cuts and scrapes at home, or the stuff that you're pretty much sanitizing everything with because of #COVID. That is a chemical that is pretty flammable. Notice the 3 in the red quadrant. Not very reactive, and a health hazard of 1. We're hoping for somewhat of a health hazard because we want it to kill all the darn viruses and bacteria, right? Yes. So now that you know a thing or two about OSHA and NFPA safety labels, keep your eye out for those labels all over the place. You'll end up noticing them at the gas station, you'll see them in your Walmart. When you're looking for it or when you happen to recognize it, you're like, oh yeah, that's cool, I know what that means. And you can kind of get an idea of how dangerous a certain area is based off of that label. Hopefully you should be able to determine the differences between OSHA and NFPA safety labels on chemicals in your daily life and in a lab setting. You should hopefully recall that the OSHA labels are the ones outlined in red in a diamond format, and they have one single picture in them, whether they're a dead fish gone belly up or a skull and crossbones, and what those each mean. You should be able to identify each quadrant of an NFPA label, blue for health hazard, red for flammability, yellow for reactivity, and white for any special kind of hazards. And also keeping in mind that 0 means it's not going to hurt you, 4 means pretty dangerous. That's the worst it can get for that category. And hopefully with that information, you should be able to determine any chemical's relative safety based off of seeing those labels. So hopefully now if you were to see a bottle like the one behind me of methanol, you should be able to determine how flammable that is from the red quadrant, how reactive it is from the yellow quadrant of the NFPA label, how much health hazard it has in the blue quadrant, and if there's any special considerations in the white quadrant. You should also be able to check out these OSHA labels behind my head and determine, hey, is there anything I should directly be aware of that will hurt my health, be poisonous, or super flammable? I hope this lesson will keep you safe from any chemical harm that you may encounter in your life. And I'd love to hear about any of the NFPA or OSHA labels you bump into on your weekly or daily routes. Please post those in the comments below, with or without a picture if you could. That'd be awesome. I'd love to see what you guys bump into and what the chemical is. Stay quacky, my friends. Stay quacky.
No ducks, no glory.